Hi guys. So today we're going to look at solving log and exponential equations, but before we do that, we're going to review some of the things that we did in the last two classes that are going to help us with solving. Now we are going to have a performance task next class that when I come back about these things. So we're going to review them now because you'll use them for solving, but we're also going to have a performance task over these things the next class. So the first thing we're going to look at is how to rewrite between log and exponential form. So if you remember, if I want to take log form and I want to turn that into an exponential equation, what I do is I take the base of the log, which is the number that's written in the small font, that becomes the base of the exponent. Then I just switch my other two numbers. So this would be 2 to the third is equal to 8. So the base of the log is the base of the exponent when I rewrite it. Same thing going the opposite way. If I rewrite this 3 to the fourth, 3 is the base of the exponent. So 3 becomes the base of the log. So this is going to be log base 3. Then I switch the other two numbers. So 81 is equal to 4. So that's converting between log and exponential form. We're going to use that today. What we're also going to use today are our properties that we did last class. So if you remember, if you have multiplication in the argument, you can separate that into two logs that are being added. If you have division in the argument, then that becomes two logs that are subtracted. And then finally, if there's an exponent, that exponent can move to the front and be multiplied by the log. So we're going to use those properties for today. So we're going to use these things to solve some different types of equations. Now the only thing that makes these equations difficult is that you're going to see 3 or 4 different types of equations, and we need to be able to recognize what type it is so that we know how to solve it. So the first type of equation that we're going to look at is if there are logs on both sides. So if we don't see any numbers that are by themselves, we only see logs. So our first step is going to be to expand or condense any logs that we can. So we're going to use those properties to combine any logs together. Once we do that, then all we need to do really is cancel out the logs that are there, and then we can just solve for x. So this first one is an example of that. So these two logs on the right side, I can condense those using the properties that we did last class. So last class we said if you're adding logs, you keep the same base and we multiply the arguments. Now, since those are two logs with the same base, all I need to worry about then, I can cancel out those logs, and I can just say that this is 6 equals 3x, and then divide by 3, so I get x equals 2. Now this works again if everything on both sides is a log. Now what we need to make sure of, if you noticed, I didn't cancel out the logs at the very first step. I can't just cancel those out and just say it's 3 plus x. I have to combine them together first. So looking at number 2, again, I have to combine these two logs together first. So using 5 logs that are subtracted, I can divide those arguments. So this is x divided by 3. Now that I just have one log equal to another log, I can just make the arguments equal. So to solve this one, I would multiply both sides by 3. So I get that 9 is equal to x. Now when you're solving these equations, remember we can check our answers the same way that we've checked our answers for all these equations so far. We don't want to use an equation solver because if there's more than one answer, it won't give it to us. So we're going to check these by graphing. So whenever we check by graphing, the first thing we do is we set it equal to 0. So I'm going to move that log base 3 of 6 to the other side so that's equal to 0. So this is going to be log base 3 of 3 plus log base 3 of x. Then it's going to be minus log base 3 of 6. And I'm going to graph this. Remember, when we graph it, we don't plug in the 0 equals. Okay, we're just going to plug in that part into my y equals. Then we're going to do gsolve. And we're going to look for our roots. So set it equal to 0 and find our roots. So I'm going to show you this on calculator. So remember, when you are graphing, we're not going to see that equation right away. So I need to do option, and then I select calc, and then I'll see the log AB option. So I can enter log base 3 of 3 plus, again, option, calc, log AB. So log base 3 of x, and then it's minus log AB, log base 3 of 6. So then I'm going to graph this. I'm going to do gsolve, and I'm going to find my roots. And again, we always want to check to make sure there's not another root. If you don't get an answer, it means one of two things. It means either there's no solution, or it means that our window's not big enough. We need to zoom out a little bit to be able to see our window. So if you look at that question that we checked, we got a root of x equals 2, and that's the same answer that we got here. So even if you are struggling with the algebra here, you need to know how to check these answers in the calculator so you can at least find that correct answer, or you can use it to check to make sure you're doing these correctly. All right, so let's look at a couple more. So we're going to do some more that have logs on both sides. So again, using those properties, if I have a number in front, remember that number in front becomes the exponent. So this becomes log base 10, 2 to the x. Once I have logs that are equal to each other, all I need to do is set the arguments equal. So 16 equals 2 to the x. So in order to find what x is, I need to know that missing exponent, 2 to the 4th power, is 16. So x equals 4. Right, same thing on 4. Take the exponent, or the number in front, make it the exponent. So this is log base 4, x to the 1/2, which if we want, we can rewrite that as log base 4 square root of x. And then I have a log equal to a log, so square root x is equal to 4. So to get x by itself, I would just square both sides, so I get x equals 16. So this is one, if you were to check this by graphing, you would need to make sure that your window was large enough so that you could see this value. So you'd need to zoom out a bit to be able to find it. And remember, if you're going to check it by graphing, I would set it equal to 0. I would subtract what's on the other side. And then I would gsolve and find my roots. All right, we're going to do 2 more that are in this form. So if you feel comfortable, you can pause this and try these too. All right, so I'm going to go ahead and combine these two together. First thing I'm going to do is I'm going to move my exponents. So this becomes log 4 to the 3rd minus log x squared. Then using those properties to condense, if I'm subtracting logs, I divide the arguments. So 4 to the 3rd is 64 divided by x squared. Since I have a log equal to a log, I can just take the arguments and set them equal to each other. So in order to solve this, I'm going to multiply both sides by x squared. So I get 64 equals 16x squared. Divide by 16. So I get that x is equal to the square root of 4. So usually we say it's plus or minus the square root of 2. In this case, it's actually only going to be 2, because when I plug it back into my original function, remember we can't have that negative argument. So my answer here is just x equals 2. All right, and the last one, again, take that number, make it the exponent. So this is natural log of x squared. Since I have a log equal to a log, I just set the arguments equal. And this time what we have is quadratic. So in order to solve a quadratic, I set it equal to 0. Then I can factor. So I'm looking for numbers that multiply to -6 and add to -3. Sorry, add to -1, which is -3. So my two answers that I get are x equals 3 and x equals -2. But again, we need to double check that we don't have extraneous solutions. That -2 is going to be an extraneous solution because when I plug it back in, it gives me a negative in that argument. So my only answer here is x equals 3. Alright, so that's what we're going to do if we have logs on both sides. So we condense what we can condense, and then if you have a log equal to a log, you just set the arguments equal. Now, sometimes, though, we have some different equations. So if we have just a log on one side, or if we have something that's in exponential form, the first thing we need to do is we need to get what has the variable by itself. So if it's in exponential form, that's something like 3 to the x equals 8. In order to solve this, I would rewrite it in log form. So that's why it's important to know how to switch back and forth between the two. So this could be rewritten as log base 3 of 8 equals x. And then if I want to find that value, I can plug that into the calculator. If I'm going the opposite way, so let's say I have something like this that's in log form. So since the log is by itself, I would rewrite it in exponential form, and that's how I would find my answer. And just remember, if you see ln, right, ln is the same thing as log with a base of e. So if you see ln, the base is e. And if we're trying to take e and we're trying to write it in log form, remember log e is actually ln. So let's do a couple of these. All right, so I find where my variable is. My variable is in the exponent. So I get the base by itself. It's already by itself. So all I have to do here now is write this in log form. So this is going to be log base 8 of 10 equals x. So x is by itself. So at this point, all I need to do then is just plug that into my calculator. So I'm going to go back to my normal screen. And to find log AB, remember it's math, log AB. And I'm doing log base 8 of 10, which gives me 1.11. All right, look at number 2. This time the variable is in the log. It's in the argument of the log. So we're going to have to write this one in exponential form. The log is already by itself, so I rewrite it in exponential form. 4 to the third is equal to x. And 4 to the third is 64. So those are the two different types of equations. It just might take a little bit of algebra just to get to that step. All right, let's try our next one. So e to the x equals 20. So the exponent has the exponent is already by itself. So I'm going to rewrite this as a log. So this would be log base e of 20 equals x. But instead of log base e, remember log base e is ln. So ln 20 equals x. So then all I would do is on my calculator I can plug in ln 20. So ln of 20. And I get 2.996, which will round to 3. So same idea on number 4, except before I rewrite this in log form, I need to get this by itself. So in order to get that by itself, I would start by subtracting 5. Now that the exponent's by itself, I need to write this in log form. So it would be log base 10 of 55 equals x. And remember, in this case, if it's log base 10, if I don't write that base, that's okay, because that common log doesn't have the base written down. So again, I would just plug this into my calculator and get my value. And I get 1.74. Alright, so looking at a couple more examples. Again, process here, if it's a log, I get the log by itself first. So in order to get that log by itself, I need to divide by 2. So now I get log base 3 of 3x equals 4. Since I have a log equal to a number, I need to write this in exponential form. So 3 to the 4th equals 3x. So 3 to the 4th is 81. So then I would just divide by 3, and I get that x equals 27. All right, and number 6, again, get the what has the exponent by itself. So I'm going to subtract 5 from both sides. I can divide both sides by -1. And now I can rewrite this as a log. So I can write it as log base e, or I could just say ln of 3 equals x. And then I can just plug that in to get that value. So ln of 3 So ln of 3 is 1.1. All right, number 7, again, we need to get what has the x by itself, so I need to get the e by itself. So I'm going to divide by 3. So I get e to the 2x equals 25 divided by 3. If you want to go ahead and turn that into the decimal, you can, which is 8.33. Then I would rewrite this as a log. So it'd be log base e, or ln, of 8.33 equals 2x. So then my last step would be to divide by 2. And we'll go ahead and plug that in to get our answer. So ln of 8.33, and then I'm going to divide that by 2. And I get 1.06. All right, so number 8, very similar. It's just going to be a little bit different in our last step. So I'm going to start by getting the log by itself. So I would subtract 5 from both sides. Since I have a log equal to a number, I'm going to rewrite this in exponential form. So the base of ln, even though it's not written, ln is really log base e. So this is e to the -1 equals x to the 4th. So now to get x by itself, if it was x squared, I would take the square root. So since it's x to the 4th, I'm going to take the 4th root. So I'm going to take the 4th root of both sides. So the way I'm going to plug that into my calculator, to do the 4th root, I'm going to do, if you look above the exponent button, there's a little x with a square root. So if you do shift and the exponent, that's where that button is. So I'm going to do the 4th root, and then e is right above the ln. So I'm going to do shift ln, and that gives me e to the power that I'm trying to put in there. So that's e to the -1. Now, if you ever need to use just regular e, this always makes you use an exponent. So if you needed e without an exponent, you would just make it e to the 1st. So that gives you your value, which is 0.78. So my final answer here would be 0.78. All right, let's look at our last couple. So same process here. I need to get either the log or the exponent by itself. So these are all logs, so we're going to get the log by itself. So on this first one, I would subtract 2. Divide by -1. And now that the log's by itself, I can rewrite it in exponential form. So in exponential form, this would be 2 to the -4th equals x to the 5th. So to get x by itself, I would have to take the 5th root. So I'm going to do the 5th root of 2 to the negative 4th. So the 5th root of 2 to the negative 4th. So again, I'm going to do shift and the exponent. That allows me to do the 5th root, and then it's 2 to the negative 4th, which gives me 0.57. All right, number 10. The log is already by itself, so I need to write this in exponential form. So ln has a base of e to the 25th equals 5x to the 3rd. What makes this one a little bit different, I need to go ahead at this point and go ahead and take the cube root, because 5x, that whole thing is being raised to the 3rd power. So I'm going to take the cube root. So the cube root of e to the 25th. So shift and exponent, cube root, shift ln of e to the 25th. That gives me 4,160. Then I can divide by 5 to get my final answer, which is 832. All right, number 11, go ahead and write it in exponential form. So 4 squared equals x minus 5. So 16 equals x minus 5. Add 5. And there's my answer. So x is 21. And then our last problem, again, we need to get the log by itself. So log base 2 of x to the 6th equals 14. So now I'm going to write this in exponential form. 2 to the 14th equals x to the 6th. So since it's x to the 6th, to get x by itself, I'm going to take the 6th root. So I'm going to take the 6th root. So the 6th root of 2 to the 14th. So that's the 6th root of 2 to the 14th. And that gives me my final answer of 5.04. All right, so just to recap, if you have logs, only one log or only one exponent, then you need to get that log or exponent by itself and rewrite it in the other form. Then you can solve for x. If you have logs on both sides, condense them using those properties that we've done, and then you can just set the arguments equal to each other. Now next class, when I come back, we're going to go ahead and review this stuff again, so we'll get a chance to review it together before your quiz, but we are going to have a performance task when I come back over the stuff from the last 2 days, which is over the 8.4 and 8.5 homework assignments. So if you have not finished those, make sure you work on those today. But that's going to be what your next performance task is over, and that's going to go over converting between log and exponential form. It's going to talk about the log graphs, and it's going to be the condensing and expanding. So converting log graphs and condensing and expanding using those properties. So condensing, expanding, and converting we're using in this assignment. So if you really want to review for that performance task, this is homework assignment's really going to help with that, but also make sure you go back and you review the log graphs from the first day's homework.